So let me start with a little bit of about us. Auth0, we are a company based in Seattle, but we have obviously presence in everywhere. We have customers in 150 countries. Sandrino is our first employee in Europe, the local guy. And Europe is, of course, a very important market for us. I was telling Morten before that for some reason, Denmark and the Netherlands and the UK are one of the most progressive in terms of adoption of new technologies and cloud services and stuff like that. This is where most of our growth is in Western Europe. So kudos, thank you. We are a company specialized in identity management. So what we do is we provide a service and software to, so you don't have to worry about authenticating users and authorizing users on any application on any stack. We are a developer company, so our product, and it's designed with developers in mind. We are all developers in the company. So we are all about removing the complexity of dealing with identity management protocols or anything around authentication. Authentication is one of those things that it's deceptively simple. How hard could it be to check a username and a password? There's nothing very hard about that only. But then quickly, very quickly, you start asking questions like, how do I store the password? Well, you shouldn't store passwords to begin with. You should hash them. Well, how I hash them? Well, there's different algorithms to hash a password. How do I recover a password that is forgotten? How do I verify that somebody that has signed up to a service is who he says he is, and owns an email that he entered? So, very quickly you start adding all these, and it's like death by 1,000 cuts. You have all these wrinkles here and there, and identity usually is it's a very small part of an application. The use cases in an application are way larger than just identity, but it takes usually disproportionate amount of effort to get it right. And username and passwords are the simplest form of identity. If you think about integration with social networks or God forbid, integration with enterprise systems like Active Directory and LDAP and SAML-based systems or WS Federation or WS Trust. It's a little bit like programming communications down to the chipset as opposed to programming with sockets or with the HTTP protocol. So if you use that analogy, Auth0 is about bringing the HTTP for identity. So you don't have to worry about all those details. OK? Any questions? Anybody heard about Auth0 before? Good. Very good. So let's go to the overview picture to begin with. And let's explain conceptually how we work. And it's not really surprising, perhaps, how the system works. We are this intermediary between any source of users and any of your applications. So we are like an abstraction on top of any way of authenticating users. The value proposition here is that you code against a single interface. Once you connect your application with us, you can then choose how you want to authenticate without any changes in your app, right? We support any application that it's able to send an HTTP request over the network. And that's virtually any application in the world, right? And we support a very large number of systems on this side as well. We will see that in a second. The other two very important properties of Auth0 is that it is a service that we run for you. It's a cloud service that we offer. But it's also it's a service that can be repackaged and deployed in dedicated instances. So security is usually very sensitive in different environments. And a lot of our customers are OK in relying on a cloud service for this. But a lot of our customers are not, because they are in financial services, they are in industries that don't yet allow to fully take advantage of a public cloud infrastructure. So we can deploy Auth0 in your own cloud. If you have an Amazon account or a Microsoft Azure account or DigitalOcean, we are able to deploy Auth0 in your own environment. Or we can package Auth0 in a server and put it in on premises, if that's needed. A very common analogy that we use is that of a database. Who develops databases today? Only specialized companies. If you're building, business applications, you are typically using a database. And like a database, like SQL Server or MySQL or MongoDB, you can deploy it in your server or you can deploy it in the cloud. All you need to change in your app, it's a connection string. Oversimplifying a little bit, but generally that's the gist. Here is the same thing. You can deploy Auth0 anywhere, and then you can change the connection string in your apps, and everything else will work. It's the same UI, the same API, the same documentation, same capabilities, everything is the same. And the other thing is that a lot of other identity platforms are very specialized in a suite of use cases, but they fail when you need to go into the last mile integrations. So when you are doing things that are special, and guess what? Everybody has special conditions. Oh, I have this old database here that I need to connect with, or I have this old application over there, or every time somebody logs in, I want to do X, Y, and Z, and those are not easily implemented in many services out there. We have fantastic extensibility features we want to show you, and I'm happy to also share how we are doing those, how we're implementing those extensibility stories in a secure way. The question was, where do you save credentials? Well, the answer is really, in many cases, we don't save any credential. Because when you're logging users with, let's say, Facebook, or Google, or Twitter, or some other external system, credentials are stored with them. So in that case, there's never credentials that are stored in Auth0. If you have a custom store, an existing database with username and passwords, you can connect it to Auth0 as well. And in that case, we don't store any credentials. If you don't have a database, or if you don't want to rely on external systems for authentication, we store user credentials in that case. We will cover that in the demo. In that case, we store it. But you have a lot of options in doing that. Let's go to the dashboard now. So when you get an account with us, you will see this. And this is our configuration dashboard. The right side and the left side of the diagram that I showed you before is all defined here. When you create a new account with us, the first thing you need to choose is where you want that account to reside. And there's two options today. You can create an account in the US-based infrastructure, or you can create the same account, an account in the European infrastructure, which is this selection here. When you choose one or the other, all the information, all the configuration, all the traffic network traffic is located in one or the other, right? So once you create an account, you get this. And as a developer, the first thing you do is you create, let's start with the normal path, you create a record for your app. You register your app with us. That's essentially creating the relationship between the left and Auth0. So your app knows about Auth0, and Auth0 knows about your app. How you do that? You go to Applications, you enter a name for the application, you click on Save, and you're done. That's all you need to do. With that, Auth0 enables all the common protocols that are available for exchanging security information with an app. So protocols like SAML, WSFed, OpenID Connect are all enabled already with reasonable defaults so it just works for the most common use cases. The default protocol that we use for applications is OpenID Connect. Anybody familiar with the protocol? Good. So OpenID Connect is an identity, it's an authentication protocol built on top of Auth0. Auth0 was not really meant for authentication. It was really meant for authorization. So it's like the use case where I want to consent access to my Facebook account to another application. So instead of sharing my credentials, I go through a protocol that allows that exchange to happen securely and then revoke access if I don't want to share any more data with anybody else. But it wasn't meant to be an authentication protocol. You can use it for that because there's like an implicit authentication in that flow. But OpenID Connect is a protocol that it's specifically designed for authentication. And the biggest change between Auth0 and OpenID Connect is the artifact that it's used to identify a user. And that's called a token. And it's more specifically, the token format that it's mostly used is one that is called JSON Web Tokens. Have you heard about that? I'm sure you've heard about it. So JSON Web Tokens are more modern if you've done anything with SAML in the past. SAML is like a XML fest where it's complex to deal with, a complex syntax. It has a lot of options, for a good reason. Right? There's good use cases for SAML. JSON Web Token is a little bit what JSON did for data structures, but for security tokens. And we will go into that detail in a second. But what we do after authentication is giving you a JSON Web Token or a JOT. It's, you will probably hear that name often. So we created an app. We register the app in Auth0. The next thing we do is we ask you what type of application you're building. And there's many options. There's 4 options there for families. If you're building a mobile app, if you're building a modern single-page application with frameworks like Angular or Ember.js and the like, React, etc., a regular website, or hybrid mobile applications with frameworks like Cordova or PhoneGap or Ionic or the ones. The first example of how developer-friendly we are is that we have SDKs for everything. So if you're building a mobile app, so if you click on I'm building mobile apps, well, all the usual suspects are there. So let's say you're building, any preferences of platform? Android. We have a vote for Android. Xamarin. Let's do Xamarin since we are in the .NET user group. Let's go with Xamarin, multi-platform mobile development using .NET. So you click on Xamarin, that's the front end of your app. That's the mobile app. Then you choose the back end of that app. Normally you have the mobile device and an API that you interact with. So you tell us which API you're connecting to. Let's pick up Web API, ASP.NET Web API. And with that, we give you 2 things. We give you the front end, and we give you the back end. And in most cases, you get this big orange button that it's what we call a seed project. That's a Hello World project that comes pre-configured with all your account information. So you literally download this. You click on download. You install it on your machine. You open Visual Studio. You press F5, and it works. There's nothing else you need to do. There's no copy-paste of URLs or client IDs or anything. Anything, it's already pre-configured there. So if you don't want to start from a Hello World app, if you want to just integrate this with your own existing application, then you follow the instructions in the tutorial. So step number 1, you install that NuGet package. Step number 2, you add those namespaces. Step number 3, you would do something like that. 4, 5, etc. Notice that our code snippets are also configured to your account. So you don't have to go and fetch settings in different places. You literally copy-paste that code snippet. You put it in your project, and it will be ready with the right values. So you won't waste time on anything that is not your application. And then you're done. The same thing will go on the Xamarin side. So on Xamarin, you follow these instructions. You follow the same code snippets like this one. And notice also the URLs and client IDs are also there. So copy paste, and you're ready to go. Now you have a Xamarin Hello World app talking to a Hello World web API. So that's on the experience of registering a client. Let's actually go and try a website now. So let's click on regular web application. So all these are popular frameworks for web applications. So popular languages and stacks. Let's click on ASP.NET. Great. Same thing. You get a Hello World scaffolding project, like before. Follow the instructions. But now let's move forward and take a look at what your application will actually look when you finish that integration. And we can see this because this is a website, so we can render the actual website. So this is like a simulation of your website once you complete the integration successfully. And this box here that we see here, we call it the Auth0 lock. That's a UI component that does authentication. And in this sample app, we have 5 different options to log in users. You can log in with Facebook, you can log in with GitHub, you can log in with Google, with Live ID, or with regular username and passwords. Right? That's because the account is configured in this way. This is, of course, fully customizable. Nobody uses the lock as it looks like this. You can change the look and feel. You can change the logo. You can localize the text. You can put videos in the background. You can use your own CSS, all of that. So see, those are like 3 examples of customers that allowed us to show to the world what they've done. So you see how they changed look easily the look and feel of the component. But this is all optional, really. You don't have to use this UI or the customization of the UI. These are like helper libraries that do everything for you. But what's happening really is that when the application wants to log in a user, it's actually redirecting or actually getting that URL. You see, and if you know the OpenID Connect protocol, you will recognize some of those parameters in the request. There's a response type, there's a scope, there's a client ID that identifies the app, there's a redirect URI, which is a callback when you're done, and then there's the connection, which identifies how you want to authenticate users. So if I clicked on Google Auth0, you will be redirected to Google to log in with a Google account. Yeah, there it is. It's going to fail because there's no application. So we're going to come back to nothing. Very good. So any questions?
You are using only get method of web. Here I see you are using get, and you don't use post or any other methods.
No, the OpenID protocol uses a get against a URL, which is a authorized URL that initiates the transaction. There's post when you're using different flows of authentication. So if there's another flow in the OpenID Connect protocol, which is the resource owner flow, and that's a protocol. It's an endpoint where you send credentials as an owner of your resource, and then you get back a response. So that's a post because you send username, password, and other things in the body, and then you say there's no UI. You don't need to redirect anywhere. You just say, I'm this user, this is my password, I'm in or I'm out.
So the only security is HTTPS. If it is not HTTPS, or if somebody can hack HTTPS, means all the credentials are viewable.
Yes, if somebody hacks into HTTPS, you are in problems. Like 99% of the web in that situation, right? So yes, that's not the only security. we would never recommend you do any of this over HTTP first, much less protocols that require you to send credentials. So you never do, none of our APIs are available in HTTP. You cannot not use HTTPS. The second thing is that the result of the authentication, we will see, is a security token. And the security token is a signed artifact. It's a document that has a digital signature. So even if somebody gets hold of that token, somehow, they would not be able to change the contents of it. So you would say, oh, I want to pretend to be somebody else. I want to change your name, your roles, your entitlements, your permissions. You cannot do that because you would be violating this signature. Yeah?
So in this case, I think it should be reported that this license is revealed and somebody else access to that license, and it should be, cancelled.
Yeah. So well, if you don't use HTTPS, you cannot interact with the service. If you violate the digital signature, if you tamper with the token will be rejected, and you will see the log somewhere. And and that's it. So monitoring and setting up alarms on different conditions, it's usually part of the value-added things that you can do around authentication, because you can detect when something is out of normal, right? Good. Yes.
When I create this account, do you then go up to Facebook and create all the keys on my behalf? And
great question. Why don't you show that?
Part of the dashboard is setting up your applications, so that's one side of the diagram. The other side is your connections, where your users are coming from. So, for example, Facebook. So you can enable or disable the connection to have it visible in the log or enabled on your application. But on top of that, we set it up with the Auth0 keys by default. So when I try to log in, you'll see the typical consent screen where you'll see Auth0 is trying to access your personal information, your friends, all those things. So on all of our connections, you can actually click the link how to obtain an app ID or client ID. And we actually show with screenshots how you can get that information.
So it will never be my app, or it can be my app on Facebook, but the default is that it's your app on Facebook that people will interact with.
Yeah.
So it's your tokens, basically. The follow-up question is Facebook okay with you as a company having my credentials for my app? Everyone is okay with that? That's not a problem? Or?
Well, you typically use that, our keys, for development. And once you go to production and you have a production Auth0 account, there you'll always set up your own client or app ID and app secret, because for your production app, you'll want the name of your company showing up.
But then I'm guessing that the tokens that you store all the tokens from Facebook and my credentials to Facebook, so all the tokens is flowing through all of your system. I can't remember what Facebook says in their policies about these things, but wouldn't they recommend that you don't share these things with other companies?
Well, they would not recommend, distributing these. These are credentials, right? Sure, it's our server, but this is your account. We never, it's your data, it's your information, it's your settings, and this is part of that. Of course, in the extreme, you can have your own Auth0, and therefore, we don't have access to anything.
But I see the trade-off that I get a lot of benefit. I save time by giving you this. I was just more asking you about, have you had any problem with all these people saying no, you can't use? Okay.
It's like a little, we see ourselves as an infrastructure component. So it's like SQL Server. You have a SQL Server somewhere, or SQL Azure, or infrastructure in the cloud. You use it to store your applications.
I think that's a good example.
So it's the same thing. We are like SQL Azure in that sense. Having said that, though, anything that is sensitive, like client secrets or connection strings to databases or passwords or everything, we never store them in our storage in clear text. not even this. We store it encrypted with a key that is unique, for your account. And so if somebody compromised our database, none of your sensitive information will be available. They would have to also compromise our servers, our service servers. Yeah? Good question. Nobody uses our dev keys in production for real, because the branding, maybe we should jump on the first demo that we have. You will see that when you log in with Facebook, it says, oh, Auth0 wants to know your name, your email, and the city that you live in. And nobody wants to see Auth0 because it's like, wow, I'm logging into thiscoolapp.com, not to Auth0. So what you want is your own branding, your own, and you end up using your own credentials all the time.
What happens if a user has given consent to the dev keys for Auth0 and then tries some other companies who's also using Auth0, using the dev keys? Will he just be giving consent automatically, or a separate account?
No, because the application that you register, it would be, in that case, it would be the same application.
Yeah, right? Yeah.
That's why it's used normally to get test quickly, and then you would use it for real with your own accounts. Yeah. And then with your account, of course, you get your own account. So it doesn't show here, or it shows in the URL that we showed before. Like you see that your account your callback will be something like, Sandrino.auth0.com callback, which is different, of course, from Eugenio Auth0.com callback. Yeah.
What do you return when the authentication is successful?
If the authentication is successful, then we will continue the transaction and we will return a security token to the app. If the authentication is unsuccessful or the user cancels and says, no, I don't want to give consent, then we return to the application with an error.
And do you return user profile, for example, from Facebook or?
Yeah, we'll see that in action. So let's jump into the first demo that we have, or I guess the third demo.
Yeah.
Now, this is, let's see, let's start with a regular, we start with a regular website?
Yeah.
Let's start with the regular website, ASP.NET MVC regular website, and see how what the flow looks like, what the experience is for logging in, what you get back, and how it works.
I'll start by creating or by showing the actual web application, so you get a feeling of how it looks like and how the flow can be, and then we'll dive in setting it up in Auth0 and looking at the few lines of code you'll need to add to make it work. So an example we have on GitHub is Faricam Timesheet, and this is an ASP.NET MVC application with OWIN, which has been set up for multi-tenancy, so a real application. And so in this application, we've integrated the log when we've seen when setting up the application. And so for this specific Auth0 subscription, I enabled Google, Facebook, Microsoft account, and also Azure AD. So when I log in with, let's try a Microsoft account. I'll start from an incognito session so you can see the actual login page. So what happens now, my application will redirect me to Auth0, and Auth0 immediately redirects the user to the Microsoft account login page, where I can log in. So when I log in, Microsoft will redirect the user back to Auth0, and there the flow will continue to your application. So now we're in a web application, so the flow we're using here is a code flow. So when the user gets back to Auth0, Auth0 will send or redirect the user back to your application with an authorization code. So not the actual token, not the actual credentials, but an authorization code. And your application, which has the client ID and client secret for Auth0, can use those credentials together with the authorization code to get the actual user credentials and the user's token. And based on that information, your web application will set a cookie, and then your user will be authenticated in the application. And so in this case, I logged into the MVC application, and here we're showing the user's claims. So we have the user's email address, the user's name. We know that the user logged in with Windows Live, and we actually even get the provider access token. So this is the token you can use to call out to the Microsoft APIs, to the Windows Live APIs, and to act on behalf of the current user. So when you log in with Facebook, you'll get an access token for Facebook, and you can get a list of friends for that user, additional information, if the user granted you access to that info. And so basically, when I'm authenticated, my ASP.NET MVC application will have set some cookies. Not sure if you can see them, but one of the cookies is the ASP.NET application cookie, and this is like the Forms authentication cookie. And this actually defines that your user is logged into the web application. So if I just delete this cookie, let's delete this one also, and I refresh the application, we can see it here. But when I refresh the application, I'm no longer logged in, and I need to log in again. So your application, in the end, will control if the user is logged in or not based on that cookie. Okay? So what I can show is how you would typically set up that ASP.NET MVC application to work with Auth0, to protect it with Auth0. And so basically, this is all the code you'll need to protect your application with Auth0. So we have a NuGet package for OWIN, for classical ASP.NET. And so basically you will use, or you can use RSDK and just enter your credentials you'll find in the dashboard. And that's it. Your application, your users can now log in through Auth0 to your application. And so this is the standard OWIN setup. If you're not using OWIN, you'll have a similar setup, but other NuGet packages, maybe adding something to the web config. But in a few lines of code, you can integrate Auth0 with any stack you're using. And so in ASP.NET MVC, to protect specific actions, you would simply use what is available in this platform. So in this case, I'll have the timesheet entries. Well, we're not using the attribute here, but if you've used ASP.NET MVC or Web API before, you'll know the authorize attribute that you'll add to your actions. Well, we simply plug in with that. So you'll use what you've been using for forever to protect your applications, but you can now easily plug in Auth0 in those applications. Okay.
So there was a previous question on the user profile, right? What is it the information that your application gets, and how is it created? So when you run the timesheet app, there was a section that essentially displayed all the user attributes. There was your name, your name, your last name, and other things. These are in essence claims about you that are contained in the security token. In fact, we give you the security token. This is the actual security token down there, right? How do you control what gets into the user profile?
Okay, so depending on the provider, you can get specific information about a user. So Facebook can give you your hometown, your work history, all those things. Google might have other information, Azure AD, again, other information. So on connection level, you can actually specify which information you would need in your application. So if we take a look at Facebook, I can specify that I need the email address from the user, the birthday, the website, whatever. Now, next to that, we can also get access or request access for specific API endpoints for that provider. So if I'm making a social app where I also need access to a user's friends, I can request permissions to, when I talk to the Facebook API, to get the user's friends. Now in this case, I will not be able to access the user's likes, activities, events, because a user, when the user gives consent, will not give consent for these specific permissions. Okay? And so
when I see those things for a provider, should I read it as you have normalized all the claims, so it's the same claim, I'll get the name claim, even though the provider maybe use something else if they use something else?
Great question.
Yeah, exactly. So we do that for the well-known claims like first name, last name, email. All these claims are normalized by us.
Nickname, picture. So one might give you gravatar, the other one will give you picture URL, the other one will give you picture, one will give you last name, surname. That's part of the problem, is that each provider will give you properties that are all different. So we normalize all these well known to a common set. Of course, if I log in with different providers, you will end up with different claim sets, because one will give you more information than another one, right? The other problem that we solve with this is that scopes are usually documented in different ways. So all those checkboxes are in different places. It's difficult to find. Sometimes they change the syntax. Facebook changed it like earlier, last year. So they change all the time, and we do that work for you. So it's all in one place. They're easy to find. They're documented. So if you click on, you will see the like for some. I don't see the tooltip. Oh, there it is. I don't see it here. So each one of these, there's a document that explains what that scope does. So it's all in one place, easy to find, easy to configure. If in some cases, APIs have a very large number of scopes, like Facebook, it has a lot. And sometimes they add new, more as the API becomes more complex, more comprehensive. Even if it's not on the dashboard, you can send a specific request on your own. So you don't depend on us. If we, for whatever reason, like an obscure scope is not in the dashboard, you can still send it in the request and have that consented by the user, right? Good.
Do you mean send a request by mail to you guys and you put it into the UI, or I put it into
No, you can do it in your app.
Good, yeah.
Right away, and you say, horoscope scope. You can do that, and then you can tell us and say, hey guys, the horoscope scope is missing. We add it, right? So sometimes we miss something that changed, but we keep track of everything. If you report it to us, we will add it. But in the meantime, you can still do it and have your application running. Cool. So this is the consent screen that we were talking about before, where you're using our dev keys. So in the dev keys,
I have it in Dutch, sorry.
Yeah, it's in Dutch. It says, Auth0 wants the following information. So far, so good?
Yeah.
Your profile and your list of friends. And you never want this. The way of getting rid of Auth0 and the way of getting rid of our shield is by registering your application in Facebook yourself. Yeah, so that's a common, it's a good practice that you do that.
Okay.
Cool. So let's do something. Let's unless you guys have any questions. Anything else on the website? All applications that are classic web applications do exactly the same. You send a request, you go back, come back with a code. The code is then exchanged for a token, and that's a server-to-server call. And then you're done. But notice that there's a decoupling, and this is an important distinction. There's a decoupling between the session and the token that we give you. So you have full control of whether the user is logged in or not. And the token, it's normally a good indication of that, but it's not the only indication. We'll see how that comes handy in other types of applications. But all applications do exactly the same. So with that, let's now move on to the AngularJS sample. And it looks like we deployed a new version of the dashboard right now. So we're going to refresh. But so normal websites, regular websites, the interactions are pages that go back and forth with cookies, and we've been doing that for a long time. Single page applications work differently because you have this JavaScript running in the browser that it's normally making API calls to an API, to your API, to somebody else's API. So in a way, they're very similar to devices, right? Where you don't have Java, you might not have JavaScript on the phone, but you have code that is running there, and it's not exchanging pages with a server. You're just making AJAX calls, or you're sending HTTP requests. So the way we authenticate those applications are slightly different. So let's now jump into the second demo, co-demo, that it's an AngularJS-based app. Any of you using Angular today, or what? Good. So let's see what the interaction looks like in this case.
So I have this AngularJS with Node.js application on my Mac. So we'll quickly look at a demo of those technology stacks, and then we'll move over to a demo with ASP.NET Web API vNext, where we can also show how we, for example, support vNext. So I'll start the application so we can look at how the flow actually looks like, and then we'll take a look at the code. So let's start an incognito session here. So this is my AngularJS application. So everything runs on the client. I'm using the lock again, and then I can log in with Google, for example. And so now I'm logged in, but everything that you saw happened on the client. So instead of requiring a server in the backend that exchanges the code for tokens, we're using what is called the implicit flow. And this means that your single page application will receive the token, and this token can then be used to make secure calls to your API. So in this case, when I call the API, well, it works, great. But what actually happened when I call the API, I'm appending a header to the API call, the authorization header of type bearer, and I'm adding this ID token, this JSON web token, to that API call. And so if we take a look at a website we've made, jwt.io, this website allows you to debug JSON web tokens. So it allows you to look at its contents and use it for debugging purposes. So let me paste in the token we just received from Auth0, and you will see three distinct parts in that token. So the first part is the header, and the header defines how the token was signed. So in this case, I'm using HS256. This is a symmetric. This uses a symmetric key to sign the JSON web token. Then we have the JSON web token itself, or the contents of the JSON web token. And here you can see that we have the information coming from my Google account. We have the country I'm in at the moment, Denmark. We have the identity, so everything my application requested for is embedded in this self-contained JSON web token. And then at the end we have the signature, and the signature applies to the JSON Web Token's body. So if I were to change something in the body, like adding an additional claim that I'm an admin of the application or adding a few roles, the signature would no longer match with the contents of the JSON Web Token, and I would no longer be able to use this token to talk to my web API. Make sense? Okay.
Can we actually see this in action from the HTTP?
Yeah, sure.
At the HTTP level. So let's, if you go back just a second to the app. So this Angular app has this button that calls an API. All it does really is adds a new header, authorization, as he was saying. So if you call it, that's the endpoint that we're calling, ping. And if you go into the elements, you see there's an authorization header there with the token. That's all it's doing, right? So let's now play a little bit with the API itself, with the endpoint itself, and see what happens when we change the token, when we don't send the token, when we tweak the token, and so on and so forth.
So I'll start by not using a token with the secured endpoint, and might be hard to read, but the exception we're getting here is that no authorization header was found. So I'll start by adding one. If I enter whatever, it will not work because our API requires a bearer token. So let's and obviously it needs to be a JSON Web Token. So if I paste in the JSON Web Token our AngularJS application received upon authentication, it works. Okay, all good. You only get this message if you're authenticated. So now if we use the jwt.io website to tamper with the token, we can actually add data here like role is administrator. And so this website will use the word secret or test secret to sign the JSON Web Token. But our application, our API, has been protected with a different secret. So if we go and take a look at the Auth0 dashboard, we'll see that for our AngularJS demo, we're signing and validating JSON Web Tokens with this client secret here, which is completely different from the word secret. So when I'm debugging and I'm adapting the JSON Web Token, the JSON Web Token that was generated here was not signed with the secret I have in Auth0, so this should not work. So let's try it. I'll replace this token with the one we just generated, and you'll see that we get an invalid signature. So there's no way to tamper with the token or to issue one yourself. The tokens are issued by Auth0 and signed with the client secret defined in your application. Okay, so what we can do now, we have, like we discussed at the start of the talk, we actually have an endpoint which is the resource owner endpoint. And instead of using the lock, I could use this endpoint to authenticate users. So instead of a UI flow, I could build my own login page or build a login page on my mobile app where I'm gathering the user's credentials like email and password. I can enter it here. I can choose to which database I want to authenticate that user. And when I do this, I will also receive this JSON Web Token, the ID token. So I can use this pretty long ID token and then try my let's remove this. Okay. Oh, so it's not very visible here. So what I have running is in this virtual machine is an ASP.NET Web API project. an ASP.NET 5 Web API project actually. So it's ASP.NET vNext. And just like we've seen in the previous example, setting it up with Auth0 is very easy. And for Web APIs, you don't even have to use our SDKs. This sample, which is also on GitHub, uses a NuGet package from Microsoft. So our solution is based on standards, JSON Web Tokens with a bare authorization header. And so when I call the API from within Postman, for example, with the JSON Web Token we just generated, internal server error.
Is it running?
Yes. That should we hope. Okay. What happened now is I actually authenticated my user to the AngularJS application, right? And so this token will be valid for the AngularJS and Node.js application running on my machine, but this ASP.NET Web API, it's a different application in Auth0, so I'll need to authenticate to that specific application. Okay, so let's pick the ASP.NET vNext application and authenticate again. Okay. And so now we're hitting the API. The user is authenticated. And if we look at the user on the current request, on the context, we'll see, I don't know if it's very visible. We'll see the list of claims that are embedded in the JSON Web Token. So this makes it very lightweight to protect your APIs, because your API on each request does not need to talk to Auth0, does not need to talk to a database somewhere. It can just decode the JSON Web Token, validate its signature, and if that's okay, transform it to claims and add it to the user on the current request. So this specific endpoint will just return all of the claims of this user. So you'll see that all of the information of my user is embedded in the token and available in a web API.
Yes.
Is there support for something like reference tokens where you don't send all the claims if you want something more lightweight?
Yeah.
Yeah.
So there's actually a few caveats with a token-based architecture. It's a really great architecture from many different perspectives. One of them is it leads to easier to test APIs because you can craft tokens on your own, mock them up, and send them. You don't have to depend on a server to issue those tokens. You can be self-issued, right? So you don't have to go in your tests and go and get a token from Auth0. That will be more like a functional test. You can create those tokens yourself, call the API, and have everything run. They are stateless, so there's no dependency from your backend to any additional service to validate them. But there are a few things to take into account. One of them, which I think is where you were going, is the size of the tokens. So this one is actually pretty big. If you see, it's like a lot of data in there. And nothing prevents you from storing more information in them. And in fact, if you deal with services like Facebook sends you potentially a lot of information. So these tokens could be very, very large. We'll see there's other ways of creating more information into a token. So one of the things that you need to pay attention to is the actual size. Because if you create, although theoretically possible, to to create like a 20 megabyte token, that goes in a header and potentially goes on each request back and forth. Probably not something you want to do for performance. Even there might be a limitation on the size of the header too. So you might not be able to send them along. Some pieces of the network infrastructure might reject, you might truncate. There are cases like older versions of Safari that will cut the URL, and if you send it on the query string, in a URL fragment, it will truncate the token, and guess what? That's an invalid token, because now there's no signature, or the signature is halfway, or you're not sending it completely. All problems with that. How do we solve that problem?
By not blowing up the token like that, of course.
Pretty much, yeah. It's like don't send all the information in the first one, or through systems that might be brittle to sending very large information. And typically for authorization, you don't need all the full profile. You might need the roles, you might need permissions, you might need the name, I don't know, a few other things. But authorization in systems which are role-based or attribute-based, you need the attributes that help you make a decision on authorization. You don't need everything, your friends, your posts, your everything else, right? So, how do we don't send all the information then?
Okay, so when we made the request to the resource owner endpoint, or when we're using the Auth0 lock or your own logic, we can actually specify which information we need from Auth0. Do we need the email address and the roles and the permissions, or maybe the complete profile? And this is actually what I did here. I was asking for OpenID profile, and this returned everything we had and we received from Facebook, for example. Now, when I need less information, I can actually specify that I would like OpenID email, OpenID email permissions, OpenID email nickname roles, for example. So if we take a look at the JSON Web Token we just received when calling the resource owner endpoint, you'll see all of this information. And this is what defines the size of your token, because you're storing all of this in the token. So when I choose to use just the OpenID scope, which is the bare minimum, we'll also get our ID token here. And if we look at the ID token, let's replace this one, you'll see that it's much smaller, right? So the size is already very compact. And if we look at the contents, if we look at the contents of the token, it contains a bare minimum. So like, what is the issuer? So where did the token come from? What is the audience? So which application, AngularJS, my web API, which application can use this token? What is the subject of the token? And the subject is a unique identifier for that specific user. And so this is a bare minimum. But let's say that my API somewhere in a specific endpoint needs my first name to do something, needs my birthday, needs my permissions. In that case, we would like to get that additional information without needing the user to re-authenticate. So we expose a few endpoints to do so, but when your API has this ID token, this JSON Web Token, it can actually use it to talk to Auth0 and get the full profile of the user. And so this endpoint we're exposing is a token info endpoint. And so if you use our API or you test it in our API Explorer, what you'll see is that you can just paste in the ID token. So the token your API is receiving in the header. And just write. And here you'll have all of the information about the user. So this information, even if it's 1 megabyte or 10 megabyte, it never has to go over the wire. The only thing that needs to go over the wire is that bare minimum that your application needs. And in the back, your application can request this additional information to do things that are not identity, not security, not authorization related.
So to be specific, it always needs to go over the wire, but not on each request. So each API call will have a small bearer token, and the backend will call this only once, perhaps, and that will go, in the response, but only once.
And cache it or add it to the session.
Store it in session. Well, there's many things you could do now in the backend. Now, can you guys think of a? Oh yes, please.
What was the difference between the token info and the user info? The user info I'm familiar with because it's in the open ID spec, right? But is the token info also there, or is that something you made up?
No, user info is like the standard endpoint for in OpenID Connect to get information about the user. For that, you use a different token. You don't use the JWT, the JSON Web Token. You use the Auth0 API access token. So the results will be essentially the same.
Yeah, but the access token is an opaque value which has no meaning.
So long story short, one is an endpoint. It's a user info with JSON Web Tokens. Yeah. That's it. We could have done it.
Yeah, but the user info is part of the OpenID Connect spec, right? I just take my ID token, ask the user for the other scopes, and I'll get them, right? Or else I remember wrong. I can't remember.
No, I think you remember right. It's user info is a well-known endpoint for the system. We could have done that too, I guess. It might seem redundant, but I think we started here and then we added a specific endpoint for JSON Web Tokens. Yeah. But yes, it should work the same. I don't think you can send. That one is not.
Here I'm in the user info with the access token.
Yeah, it's the same thing, I guess. So you use a different token one and the other, but that's the only difference. Can you think of any other potential problems with using JSON Web Tokens? Size is a good one. That's a common problem. And sometimes systems don't work, and you don't know why, because the responses are kind of cryptic. So that's one thing to keep an eye on. Yes?
What about deploying the token, compromising, and validity of the token? How long this token is valid, and actually if the token is compromised, how you can actually somehow find it out? And another thing is, how do you sign out based on the token?
Yeah, so the questions are, how do you minimize the exposure of if you lose the token somehow, or somebody gets access to the token and you don't want that? Because with a valid token, you can call like man-in-the-middle kind of attacks. So the first thing you do is you always use HTTPS. Because if somebody sniffs your traffic and gets hold of the token, they can call your API. The second thing you do is you restrict the validity of the token in time, and that's through the expiration. So if you look here, these are 5 properties that are standard in JSON Web Tokens. This one is the issuer who created the token. In this case, our server. Who is the user that this token was created for? What is the intended consumer of the token? That's called the audience, or the application that is a recipient of the token. And these 2 elements that add the time dimension to the token. So the way you minimize exposure is by having expirations that are not days. And that's very much dependent on the application that you're building. So some applications, it's fine to have, long-lived tokens, days perhaps, few days, hours. Others will be better off with minutes and only a few minutes. So if you lose them, you're only exposed during that time.
I have a question in the meantime. If a token is actually expired while the user is using it,
Yeah.
Do you have some endpoint for refresh it or?
Great question. But before that, let me answer the question on logout. So if you have a token and you want to log out, what do you do?
Invalidate the token.
Invalidate the token?
Call the sign out to endpoint.
Call the sign out?
Usually they delete the token.
Yes, that's the easiest thing you can do, is just get rid of it. Now you don't have any token, then you cannot do anything. So that's the easiest thing to do. So if you are using a combination of cookie-based sessions and tokens, you want to get rid of the token, but you also want to delete your sessions and call the single logout or the logout endpoints in whatever servers you are depending on, for example, us. So for each application, we have an endpoint that you can call. It's a logout endpoint, and it will eliminate the session with us as well. Yeah?
But the token is still valid.
If you have it, yes. If you get rid of it, it's gone. Now, let's say you are using the application, you have a token that expires in 1 minute, and what do you do? Are you going to ask the user to log in every minute? Yes, it's awesome. Enter username and password every minute would be fantastic. How do we deal with short-lived tokens, but without affecting the user experience? What can we do?
We can use refresh tokens if the code flow allows it.
Right. What is a refresh token? It's none of this. It's another thing. What is a refresh token?
So you get a token and you get another token.
Yeah, a refresh token, it's another token that we give you, or like a system like ours gives you, that essentially never expires. And so you have two. You have the token that you use for your API that expires, and then you have this other thing that you can go back to us and say, hey, it expired, give me a new one, and then you can use a new one to call the API again. But hold on, we were exposed to long-lived, like we wanted short expirations on tokens, so we're not exposed. And now we are giving you a token that never expires that allows you to renew tokens. It sounds like it's worse the solution than the problem. How do we deal with that?
It's only some of the flows that allow it. So if you use the code flow, you have the refresh tokens, and you can actually only ask for refreshing on a backend. So if you use the other flow for the JavaScript thing, you won't get a refresh token. The user should never see the refresh token. It should be sent by backends.
So if you're building a single page application, it's never a good idea to use a refresh, to use a scope that gives you a refresh token, because the refresh token lives in the client. You don't want the user to have access to the refresh token, right? You want them in a protected space that it's not reachable, easily reachable. Maybe backend. Often refresh tokens are used in mobile devices because there the use case is not because you have like long, short-lived, like 1 minute tokens, JSON tokens, is that you pick up the phone and you log in again to an application 3 days afterwards. The token is expired, but you don't want to enter again using a password, so you refresh, right? It's a good option. But how do I lose the phone? So now, sure, the phone is not the browser, it's not in the wild. Maybe it's something that I will take care of with more care than browser that I might use in a coffee shop. But what other properties of refresh tokens can we have to implement to protect from losing refresh tokens easily?
They need to be able to revoke them.
Yes. So the difference between refresh tokens and other tokens the main difference is that refresh tokens are revocable entities, are things that you can go back without access to the device, which I have here, without access to this device, and server side say no more. So I lose the phone, and I don't remember to wipe it because I don't realize that I lost it. Yeah. So even if I don't have access to wiping it out, I can go to the server, delete the refresh token, and so even if you have a refresh token, you cannot get a new token from us. How do we delete the refresh token? So hold on, before we go there, what did you do here?
Yeah. So we have a scope which is called offline access. And when you use this scope and you specify the device, so this is typically when you're using Xamarin or Swift or Objective-C, you'll specify the device ID as a device when you're asking for a refresh token. But this value can be anything. And so when you're using the offline access scope, we will send you, in addition to the ID token and the access token, we will also send you the refresh token, which you can then use to get new tokens over and over again. But we also expose an endpoint that allows you to revoke refresh tokens. So we have this endpoint here, the delete refresh token, where you can actually where we allow you to delete a refresh token for a specific user. So now you, in your applications, you could build a UI, and that's a typical UI you'll see in Twitter, in Facebook, where you can actually revoke access to a specific application. The UI will be similar, where you can present your users their refresh tokens, their devices, and then revoke access for a specific device. And from that moment on, it will be impossible for that device to get new tokens. Yes?
Do I have to create this UI, or do you also do this as identity management for us?
Yep. So let me log into the dashboard. Let's see one of my users here. I just requested a refresh token for iPhone, and now I can actually manage those in the Auth0 dashboard.
Yeah, okay. You as a developer can do that, but can the end user actually go to Auth0 and
No, for that the typical flow is that your application, we give you APIs to show essentially the same information for your user, right? And then you can go and they can say delete, revoke, and it will be the same effect as doing this. In fact, our dashboard, it's a client of our API. So everything you do, if you don't like our dashboard, you can recreate it entirely with your own, and you would just call our APIs to do that, right? So registering applications, looking at the logs of the user, all of that can be done programmatically as well. Yeah. Now, but that, we haven't solved the problem of the website, right? The SPA, because we solved the problem of the device, perhaps, with this revocation process. But now you want small windows for tokens in the browser. Let's say a minute. Well, a minute might be too short. Let's say an hour. But it's an intensive user. Will be used for more than an hour. How do we prevent the user from logging in again? Is there anything we can do besides refresh tokens, which we know are likely not recommended for websites?
I guess you can just put on a prompt query telling that you don't want a UI prompt, and if you're lucky, you get the token back, and if not, you'll have to ask the user to authenticate.
Yeah, so another trick that you can use is that if you have a valid token, you can get another token. So while the token is not expired, you can use that token, not a refresh token, the non-expired token, to get a new one. So a common pattern is that if you're interacting with an API and everything, before you call, you can inspect the expiration and say, oh, it's only 30 seconds left, or maybe 5 minutes left. So before we do anything, we go with a non-expired token to us, and instead of using the refresh, we use a non-expired token. And then we come back with another hour there. So that's a very common pattern for refreshing with no refresh token.
Is that part of the OpenID spec?
No.
Or no?
But we allow that because it's very useful. Yeah. Great. So let's see. Any other potential issues or concerns that you can think of this approach? Yes.
What about single signing?
What's that?
Single signing. If an organization wants a single signing, do you have any solution for that?
Yeah.
It's another. I know it's another area. And
it's related, but yes. So let's go to the. So here's what would happen. Let's say you have two applications connected to Auth0, and then you have a connection with Google. So, and let's, for the sake of the exercise, let's say it's two websites. So you go to the first website, you click on Google, you log in Google, you come back, you're logged in, you have a JSON Web Token, you're logged in the application. Then you click a link on the second app. Do we need to pause? Oh, good? Okay. Then you click a link on the second application. You're not logged in that application yet. So what you will do is the standard thing. You will redirect to our server, then we will redirect you to Google. You come back from Google, and then you come back with another token, a second token with a second audience, because now it's a different app. Because you're doing everything in the same browser, the effect is that of single sign-on, because that's what's called IDP single sign-on, identity provider single sign-on. You are already logged in Google. You don't need to log in again. You just or click if you have multiple accounts, or you do nothing and you go back, come back. If you're using any enterprise infrastructure like AD or SAML or ADFS, same effect. That's called IDP single sign-on. The single sign-on happens in the identity provider. What the user sees is like a couple of redirects, and then you are in the second application with no interruption. We also support what we call, like a federation provider single sign-on, which is you don't have to go to Google because you already are logged in with us. So there's this switch that you can turn on and turn off. If you turn this switch on, when you go to the second application, you come to us, say, we know who you are, boom, you come back. So you save the extra hop of going to Google or to AD or to whatever. So the entire effect is that you have single sign-on with them.
So it supports somehow single signing as
yeah.
approach. Thank you.
Any problems of the tokens?
But do you have the first time when you log in, you have to accept the show location, show hometown?
Yes.
On both
you only
sides?
No, because you only do once. Why you're not? That's a good question. So why you don't have to consent twice? Why doesn't Facebook ask you 2 times to consent to deliver using location, friends, and calendar and whatnot?
Because you are using the same key?
Yeah, because it's 2 applications that go to Auth0, and it's only one. So the relationship is Auth0 with Facebook. You already consented. You can, if you want, you can have multiple and re-consent. But normally we don't do that because you don't want that. You want to, all your applications share the same connection. Good. All right? There's one more thing that you have to take into account, and that's the way we sign the tokens. How we sign the tokens. You go back to the JWT.io. Not this one, precisely, the other one. So before,
let me see.
Sandrino was demoing this using the client secret, and then we changed the client secret with a word secret, which is essentially a different key. And now we sign it again with a different key, and it was invalid key, and that's fine. So that worked because who knows the key to sign the token? It's known by the issuer, which is in this case Auth0, and it's also known by the application or the API. It's a configuration that you put there. It's never the client. It's always the the API, the backend, or somebody else. So this is a token signed with this algorithm, and somewhere there, back there, there is a secret used, the key used to sign the token. The problem with this approach is that you have shared secrets. And that's fine for 90% of the scenarios. It's okay. You have an API, maybe 2 APIs, 5 APIs, a website. So you have a handful of secrets to deal with. Right? It's not a big deal in distributing those secrets. But when you have many APIs, a long, long number of APIs, distributing secrets, it's a challenge. It's a problem. And so for that, we recommend not using symmetric algorithms, but using asymmetric algorithms. Because then you can have private and public keys. You can send the public key everywhere, and that's okay. You don't have to use mechanisms that are out of band, secure mechanisms for key distribution. It's a public key. The private key stays in the issuer. And that was the other token that we saw before that we showed without planning. You see here that it's a different algorithm. And the reason I noticed that is because it's a much bigger signature. And this is saying the ID of the key that we're using, because you can have many public keys, the algorithm, and this is the signature that results of that. The advantage of symmetric keys for signatures is that they're very simple. They're simpler to implement and run. Some of the libraries, not all of the libraries support asymmetric. All of them support symmetric. And then the other reason is because they are more computationally intense. So the symmetric ones are faster, usually. Perhaps marginally faster. They are faster.
So the client should know the secret key or private key. Means there would be some negotiation between your client and your company, and your company send the keys, yes?
No, it's always your keys. It's never ours keys. They are stored in our server, in our
There
zero.
would be another handshake here.
For that, for what?
If there is one, private key and one public key, isn't it necessary to do some kinds of handshaking?
No, you just download the public key from our website, from your account, actually. Public keys are public keys. So there's an endpoint. There's a well-known endpoint for OpenID Connect that gives you a lot of information, including the sign-in certificate. So that one gives you all the information that you need. So the handshake is really a well-known endpoint which acts as a metadata endpoint. It's a metadata endpoint where you can call and get the information from us. That's the sign-in certificate.
So you give the keys to the clients, customers?
Yeah, yes, and of course you can change the sign-in certificate to whatever you want. You don't have to use the one that we generate. If you don't want.
The open middlewares that you used before is actually going up to the endpoint, getting the keys to validate the signature.
Yeah.
So if they wrote the keys or something, the application just
will just work.
support.
Yeah, yeah, exactly. So far so good. We only have like 2 hours more to go, and no, it's a joke. So we are like, let's say, an hour and a half already, I think. How are we doing? Okay. Okay. So let's see. Let us show you the one of the most advanced features that we implemented in our platform, and that's the 2 examples of extensibility that we offer that I think would be that you will like. So the first one we wanted to show you is, let's say, because you have a question on custom DB stores. So storing your own database of user accounts. So let's do a custom database connection.
SQL server? Whatever.
Why not? SQL Server.
Why? Yeah, okay. So when you create a database connection in Auth0, we will actually store the usernames, passwords, and all the information about the user in that connection. And we host that database in our cloud platform, and it's there with all the other customers. But what you can do is actually modify this connection to point to your own database. So when you enable your own database, we actually allow you to write a few scripts, and this is your code, and this can be JavaScript or C#. So this runs on the server, and you can actually write your code that will be executed in the authentication pipeline, and that can interact with your own systems. And we have templates for SQL Server, for MongoDB, or even for an external API. So if we look at the SQL Server example, this is actually just some JavaScript, some Node.js code that will connect to your database. So here you'll have the connection string or the connection information to your database. You will write a select query to get the information you need about that user. So I might need the country, city, age, some information that is in the database, together with the password hash preferably. And then you can actually write some code that compares the incoming password with the password hash from the database. If everything turns out to be okay, you can return a profile, and we can actually continue the authentication flow with that profile you assembled in that script. So you take full control of the database connection we're using in Auth0, right? So, of course, this database needs to be accessible from our platform, which means that you will need to open up that database to our IP addresses. And so these are the IP addresses we use. So our platform will be calling your database from one of these IP addresses. So you will need to open up your database in your firewall to these IP addresses. Now, yeah.
Which cloud infrastructure are you running on?
We are running on Azure, on Amazon, and on Google Cloud at the same time.
So do I pick that somewhere? Let's say I'm on Azure and I want my database being close to you, of course. Where do I tell you that I have mine in Azure also? Or do you just
well, the affinity is on geography. So it's on Europe.
I can control that particular endpoint that I have at Europe.
But normally, if you're in Europe and you deploy in Europe, close, data center to data center are pretty fast.
Yeah.
This is normally, in practice, slower, slightly slower when it's not in a cloud provider and it's running, under your desk. That's when it will be slower, right? Now, a lot of people don't want to open the.
Do we have special deals with Microsoft using higher level the backbone of the internet, or do you just use data connection?
No, I mean our experience. We like to give you a little more information. When I say we run on everything, it's because we don't have a single dependency to any cloud provider. We don't want to depend on Azure or Amazon or Google or anybody. Or yes, we depend on the three of them. If the three of them are down, in East Coast, West Coast, in Dublin, in Frankfurt, well, I guess the world has worse problems to deal with than us. But in our case, the regional infrastructure, like Europe, notice that there's no east, west, or north, south, it's Europe. And so that means that you're normally in 2 data centers. We keep 2 data centers active all the time. In Europe, it's Frankfurt and Ireland, and Dublin. So they are all the time alive. all transactions that go to one, they're always going to one. And then what we do is we replicate real time one and the other. If one goes down, we switch here where all requests go, and then we'll go all the Frankfurt goes away for some reason. We reroute everything to Dublin. And none of your information is lost, there's no backup, restore, all is taken care of. What I'm saying is that normally, data center to data center works pretty good, even across vendors. So they must have like really nice pipes, across, everything. So it has not been a problem. When you go across, we have had customers with, US custom connections coming back to European hosted databases, and hey, it's going across the laws of physics. So
do you alert the users that they might?
Oh yeah. So we monitor. This is taking 500 milliseconds. Where is this? And we look, and we normally are quite proactive in optimizing around that. So in that case, we move their database closer, or we move them. We move their account to Europe. But the important capability here is that you can write anything you want here. This is your code. You can do anything you want. You can write a database called a web service, do anything.
He said that you could write C# or JavaScript. Is there any other language? You can, what is the idea that it should be easy for us to use? And do you then run it on Node if it's Java, right? And then
no, we always run in Node. When you embed C# code in there, we extract the C# code, we compile it, we run it, and then we.
So there's no performance of one of the others. It will end up in there.
It's pretty good in both cases. We don't have right now, F# and others, but it hasn't been a problem.
The whole platform is built on Node.
Yes. The entire service is built on Node.js. So that's custom logins. The other feature that we have is rules. And this is even more interesting because it allows other things to happen. So let's go back to the document, the picture. This picture, there you go, shows conceptually how our server works. So your application requests authentication, as we talked about a lot. We send the user to whatever, Google, AD, LDAP, anything. And when you successfully authenticate, come back to us, we create a token that we send back to the application here. Now, in between these two, we allow you to inject your own code, your own functions, right? So you can put your code as part of the flow of authentication. And what you do in that code, it's completely up to you. You can write, and we call these functions rules. Rules allow you to send an event to somewhere, call a web service, call a database to query for more information about the user. You can delete properties dynamically. You can interrupt and say no access based on a condition. And you probably guessed by now, these rules are written in JavaScript or in C#. This is the same thing that we use for database connections. So let's see one in action.
Are you validating the code that the user writes, or are you saying that it's our code because you don't want the responsibility of me doing something stupid?
Oh, we'll see that in a second. It's your code because normally we see all these, long tail use cases, very specific to your organization, legacy systems that you need to integrate with, integrations with third-party systems. Let me give you an example of real-world use cases of this. Let's say you want to send an SMS to a user that is logging in from a different machine and from a different location from the last login. So it's a classic, I logged into my bank here in Denmark, and immediately I got an email that says, oh, somebody was trying to log into your home banking from Copenhagen. Is that you? Yes, it's me. There was a notification. So how would you do something like that?
If that code raise exception, what would happen?
We'll come back to that in a second. So you can go here, and a rule is a function that we give you a user, and we give you a context of the code. The user is a logged in user. It's in essence the same object that you saw before, all the contents of the user profile, name and other things. Context is a lot of information about the transaction. Your IP address, the application that you're trying to log into, the type of authentication that you used, statistics about you, how many times you logged in, all of that. It's actually all you see here. So your user agent, everything. Some of the things that we do, because it's convenient, we geocode, we create an object we call GeoIP, and we look up based on your IP address, country, and other information. Here, longitude, latitude, and so on and so forth. We do that. So now you can write a code that says if context dot IP different from the last one, from the last time. Remember, this runs on each login. So if the IP has changed and the user agent is different from the previous one, if context dot then send SMS. And we have an example that runs. We have a GitHub repo with a lot of rules that people have written. It does that with Twilio, as an example.
Could I have all my functions in a GitHub repo and change things there in source control, or do I need to enter all the code on the homepage?
You need to enter all the code in our server, but you can connect GitHub with our server, and so you can push code in GitHub, and we will push it automatically to our server. So you can have full version control through that. Yeah. So and it explains how to do that. So here we are extracting the country name, the name of the event, for all users that log in through the system. And now we run this, and
I can show it in the.
Oh, cool.
So when I log in, we'll get the JSON Web Token, and if we look at it, we'll have the country Denmark and the event C Copenhagen US Group.
Yeah.
So
let's go on to the dashboard, and let's go to rules, create rules. Now these are templates of things that we see people doing often. And one of them is the access control. So let's say a very simple one, email, the email whitelist, this one. So this one is pretty simple. There's a whitelist of emails, and if you're not in that list, we raise an exception, and this is an exception that breaks the pipeline. So you're not logged in. Yeah? So what other things you can do that are cool? You can do multi-factor authentication with this. So let's do Google Authenticator. So we are going to implement Google Authenticator multi-factor in our app. So we turn it on. All we're saying is context.multifactor on with Google Authenticator. Of course, we can put a condition there that says if the application is supercritical application and the IP address is from a network that is not your intranet, you're working from Starbucks or whatever, a coffee shop, then you want the multi-factor. But here we want for everything. So let's save this. We turn it on, and let's log out from the application. We log in again. We log in with Google.
A little too much.
MVP.
I
Well,
don't.
that's Google Authenticator, right?
There it is.
There it is. So now you can enter your code on the phone.
Okay.
Done. And now let's see what we have in the token. So now we have the same thing as before, but now we should also have here the property that it's also telling you that this is a user that has successfully passed a multi-factor challenge with Google Authenticator. All right?
Yep.
Did I miss something?
I think we covered
Are we
everything.
good? Any questions? Very good. Thank you very much.